Hello, AP Stats. We're going to talk about chi-square distributions a little bit more in this part 2 video. So key vocabulary, we are going to talk about observed counts, expected counts. We talked about that. Components or contributions, the chi-square test statistic, and the chi-square goodness of fit test. So big ideas for this unit. Chi-square tests are about distributions of categorical variables. As I mentioned before, that's why there's no parameters. You're not going to say like mu equals or p equals because we're talking about an entire distribution. So the hypotheses are not going to be stated in, or they're going to be stated in words, not symbols. The alternative hypothesis is going to be that the null is not correct, that the claimed distribution is not true in context. We don't have any two-tailed tests. We talked about that. Basically, the larger the chi-squared value, the more significant the data is going to be. And we have no confidence intervals, so it's only going to be significance tests here. So as far as the hypotheses go, in general, the null is going to be the claimed distribution is true in context. The alternative, the claimed distribution is not true. To find your expected values for each category, you're just going to take the probability times the sample size. Do not round these. They're not going to be integers in most cases, and that's fine. Test statistic. This is on your green formula sheet. You don't need to have this memorized. The larger chi-squared value you get, you have more evidence for the alternative. Because the bigger the difference is, when I start to sum these up, I'm going to get a larger and larger test statistic. Degrees of freedom, number of categories -1, your conditions, random 10%, and expected counts. Shoot, that just reminds me. I forgot to go back in my previous video, so let me talk about that now. I mentioned all expected counts are at least 5 here. That's these values here. These were all at least 5. Say hypothetically, orange was like 2.6. What I would need to do is combine these two categories and call these colors like other. I'm going to combine orange and blue so that I end up with all my expected counts greater than 5. That's just something you could possibly see. Unlikely, but possible. Okay, so those expected counts all have to be at least 5. You're going to have to show them, literally show them. Typically, that happens in the do step. Chi-square distributions are always skewed to the right. They always start at 0 because we're squaring values, differences, and dividing, so we're not going to get negatives. And if the results are significant, if you reject the null, you have to do this follow-up analysis, which you saw in the previous question. Find the largest component or contribution of chi-squared and explain it. There was more than expected or less than expected. All right, let's move on to this next page. Okay, on page 3, just so you can see how the shape of the chi-squared distribution changes as the degrees of freedom increase, the skewness decreases. So, because essentially the degrees of freedom are measuring the number of categories in this case. So you have more categories, you're going to have less skewness. It's just something in general, a characteristic of the chi-square distribution that I want you to know. As degrees of freedom increase, the right skew decreases. All right, there's going to be some multiple choice here. I think I put 4 or 5 questions in that I would really like for you to ideally work through on your own. So pause the video, work through these 5 multiple choice questions, then come back and watch me go through them. Make sure you're good. So go ahead and do that. All right, here's what we know. The animal treats 230 animals in a month. How many of each animal type would be expected? So I'm just going to follow through. This is the distribution historically. So like the population distribution. So for dogs specifically, I'd expect 230 times 0.61, which ends up being 140.3. So I'd expect to see 140.3 dogs. So the only answers that even make sense are C and E at this point. We don't round expected values. I know I can't see 140.3 dogs, so that's why C is there as an answer choice. The correct answer here is E. I don't even need to go any further. I mean, if I did, cats are going to be 230 times 0.22, livestock times 0.08, etc., so on and so forth. Okay, number 2, which is the appropriate description of the chi-square distribution? It'll only contain positive values and be skewed right, with skew being less pronounced with increasing degrees of freedom. That is true. This is saying skewed left, skewed left. Those are out. These are saying positive values, okay, positive and negative. It's not going to include any negative values because we're squaring differences and dividing, so we're summing those up. The skew is not becoming more pronounced. As degrees of freedom increase, less skewness. So number 2 is A. Okay, moving on to the next couple. How are expected counts calculated? That's just this idea of multiplying the probability times the sample size. So it's just n times p. And it's the proportion by the sample size. I think I put that as like p sub I. That's how you get your expected counts. Which of the following is not a condition for a goodness of fit test? We do need to have a random sample or a randomized experiment. We need the 10% condition. Expected counts have to be at least 5. The sample should be approximately normal. Not true, because our sampling distribution is not going to be normal. It's going to be skewed to the right. Each individual chosen should be independent. That is true. That's part of like the sampling without replacement. Okay, this next one. All right, they give you the test statistic and they ask for the p-value. I apologize, the font is very small on this. So we're always looking at shading to the right or an upper tailed test for the chi-squared. So C and D would be out. The sample size does not matter. It's just the number of categories, which we'll come to in a minute. So it's going to be A or B. So what I'm going to need to do is chi-squared CDF in my calculator. The lower is going to be 8.2. The upper is going to be infinity. Degrees of freedom, we have cars with black seats that are white, cars with black seats that are blue, cars with black seats that are red, and cars with black seats that are black. There's 4 categories minus 1, 3 degrees of freedom. And when I do that, I'm going to get, what am I going to get? I'm going to get answer B, I believe, but let me double check. Second vars, chi-squared CDF 8.2 with 3 degrees of freedom, 0.042. 0.042. Now, I'll tell you with this one, B is what I think is the best answer. If you went through this whole thing, your observed and expected counts, your expected counts aren't going to be at least 5, so the conditions really aren't met. But that's not an answer choice, so I think B is the best answer choice that we do have. Okay, moving on to page 5. So this is just going to be focusing on that first learning objective or the first learning target, like stating the hypotheses and calculating the expected values. So if we take a look at this question, this company claims that in each batch of its deluxe mixed nuts contains this percent of cashews, almonds, macadamia nuts, which are the best, by the way. If you don't like those or if you've never tried them, life-changing. And Brazil nuts. To test this claim, a quality control inspector takes a random sample of 150 and gets these results. So you have to recognize these are the observed counts. This is what actually happened. All right, part A, state the appropriate hypotheses. So no parameters, no symbols, just words. So basically, remember the null is that the claim distribution is true. So I'm just going to add context to that too. So the company's claimed distribution of mixed nuts is true. The alternative, the company's claimed distribution of mixed nuts is not true. Basically, it's different. Maybe there's more cashews or less macadamias, whatever. So that's part A. Part B, the expected counts for each type of nut. So for cashew, I expect 52% of the total amount of nuts to be cashews. There's 150 total. So 150 times 0.52, 78. For almonds, 150 times this 27% is 40.5. Macadamia, 150 times 13% is 19.5. And for Brazil, 150 times 0.08 is 12. So those are my expected counts. If I was thinking about the plan step, all the expected counts are at least 5. That condition would be met. And remember, I'm not rounding these. They are what they are. Moving on to question 2. At this point, what I would say, read through the question, do part A on your own, and then come back, check me going through it so you can have a sense of where you're at. So pause the video and do that. So part A, I'm just looking for the appropriate hypotheses to test whether we have convincing evidence that the distribution of outcomes on this wheel is what it should be. So that kind of tells you really what you're testing here. The null is that the distribution of outcomes on the wheel is as it should be. And then the alternative would be that the distribution of outcomes on the wheel is not as it should be. It's different. One number is coming up more, or one color in this case is coming up more or less than it should. So those are going to be your null and alternative. Remember, no parameters. Last thing on page 5 that we're going to start to look at, being able to calculate your chi-square test statistic, figure out your degrees of freedom and your p-value, whether you do it in the calculator or use chi-squared CDF, lower upper degrees of freedom, doing the 4-step process. If for some reason the calculator you're using, most have updated operating systems, so I doubt this is the case, but if that's the case, you can write a program to have a goodness of fit test on your calculator. This is the video on how to do that. I mentioned this briefly, just a tip. If your expected counts are not at least 5, keep combining categories until that's satisfied. So going back up to the mixed nuts here, if like macadamia was like 2.5 and Brazil was 12, I'm just going to combine these two categories. So I'd have cashew, almond, and other. And then I'd add these up and say 38 was my observed, and I'd expect 21% of those to fall in that other category. All right, I'm going to stop this video here. That's the end of part 2. And then in the next part, I'll go through a couple of these tests with you.